All right, so we're starting a new chapter, and the title of the chapter is Rational Expressions. And a rational number is any number that can be written as a fraction. A rational expression is any expression that can be written as a fraction. I like to use what I find to be a more clear definition of rational expression. I just like to call it an algebraic fraction. So for example, x plus 1 over x minus 2. That is a rational expression because you have an algebraic expression in the numerator and in the denominator. You could have something like, or 1 over x squared, or x squared minus 1 over x plus 2. Those are all algebraic fractions, or in other words, rational expressions. So you're going to be looking to have an algebraic, something with an x, in at least the denominator or the denominator and the numerator. Something like x over 4 is not a rational expression because that's just the same as 1/4 x. 1/4 x is a polynomial because you don't have the x in the denominator. So if you have x in the denominator in any form, regardless of the numerator, it's going to be considered a rational expression. And the reason this is important is because the graphs of these look completely different than graphs if you don't have any x's in the denominator. So that's why we have names for these things. So we're going to start out in 7.1, which is reducing rational expressions. And in the beginning of the section, we'll be doing some other things, and then we'll get to actually reducing them in a little bit. And I'll try and demonstrate to you how reducing a rational expression is similar to reducing a fraction. But the first thing we're going to do is evaluate. In other words, find the value of each. So for number 1, if it says evaluate or find the value of this rational expression given x equals -3, all that means is you're going to plug in -3 where you see x. So that means I'm going to write 4 times -3 minus 1, plugging in -3 where I saw the x, over -3 plus 2. So I plugged in -3 wherever I saw the x. Can someone give me the value of the numerator? Henry? -1. Can you explain how you got that? Oh, did I say the denominator?
Oh, no.
That's okay, you have to do both.
Okay, and then the numerator is
-13. Can you explain how you got that?
So 4 times -3 is -12, and then minus 1 is -13.
Good. Awesome. So that's going to give us 13. Questions on that? All right. Now, this is another way of stating exactly what we did up here, but it's just using function notation. So f of 4 means I plug in 4 where I see the x. Again, the exact same operation. It's just using what's called function notation. And so if f of x equals 3x plus 2 over 2x minus 1, find f of 4 means you're substituting in 4 for x. Bob?
Did you get 2?
Can you explain what you did?
So I multiplied 3 times 4, and I got 12 plus 2 is 14.
And then what?
And then 2 times 4 is 8. 8 minus 1 is 7.
Okay, and then you got how much?
2 over 1, which is 2.
Good, perfect. Any questions? Right. So that's evaluating an expression, and this one just happens to be a rational expression, meaning you had x in the denominator here. So when we,
I noticed that me and Charles were literally talking about this probably Saturday.
okay, well,
Yeah.
let's talk about it then. So if we consider 7 divided by 0, Jeremy, what do we get?
It would be like unsolved or something like that because you can't divide by 0.
Yeah,
Yeah.
we call it undefined.
Yeah, that.
So division is defined for any number except 0. Because what division means is how many times does the number in the denominator go into the number in the numerator? Well, 0 doesn't divide into anything. 0 doesn't go into something. You can't split a pizza up into 0 pieces. So
Unless you eat it. Wait. I think you just saw me. That's
okay, so it's pizza. Okay.
So you can speed this up.
You can eat this up. Of course. Found a way. Jurassic Park played, by the way. All right, so since we can't have 0 in the denominator, in reality, we need to exclude the values that make the denominator 0. So this is a question that leads us, okay, that leads us up to graphing. So you might be asking, why do we care about this? But it's good to know what values you can actually plug into an expression, knowing that we cannot divide by 0. So what numbers cannot be used for x?
0.
So let's try 0. If we try 0, you get 0 divided by what?
-4.
-4. What is 0 divided by -4?
0.
0.
Oh,
So you can have, no, that's a good thing to highlight. 0 can be in the numerator, because you can find out, like, if I have no pizza, how am I gonna divide that 4 ways? Well, everyone gets no pizza. So you can divide into 0, it's just gonna be 0, but you can't divide by 0.
X will equal 4.
So if x equals 4, you would get 4 over what? 0.
Oh, yeah.
So that would make it an undefined number. So the answer is 4. Go ahead, Nolan.
So if it's 7 over 0, why would it just be 7? So you're not even dividing it.
Okay, because you're asking yourself, divide 7 pizzas for 0 people. Okay, the problem doesn't make sense. You can't divide something 0 ways. Okay. So it's just when they wrote what division was, they wrote it's going to make sense for any number except for 0 when they wrote the rules for division. Yes.
How about even, so negatives are fine, it's just 0?
Yeah.
How about if it's like 0.1?
That's okay.
Okay, so anything, just 0 is like the cutoff.
All right, now let's look at this one. What numbers can't we use in place of the x? Henry?
-8.
X cannot equal -8. I could even write it this way. X cannot equal, so that's equal, and then the line curve means not. X cannot equal -8. Because if you plug -8 into the numerator, what do you get?
0, and then 63
63
over 0.
divided by 0. Good. So any number divided by 0 doesn't exist. So you can't use, it is undefined, I should say. So this is the one number that cannot be used in place of x. All right, so you're looking for the number that makes the denominator 0. Let's take a look at this one. Jerry?
Would it be 2?
It would be. Are there any other numbers that wouldn't work? guys think of -2?
Yes. It
Uh,
would? Yeah.
Yeah,
Like it
no,
wouldn't work.
yeah, maybe.
So if you
Yeah,
square -2, what do you get, everybody?
Or.
4.
Oh,
4 minus 4 is 0. So you have to, if it's squared, remember, we should get 2 different answers there. Okay? So 2 squared minus 4 and -2 squared minus 4 both equal 0. So those cannot be used. All right. So that brings us to a huge algebra concept, one that's developed a lot more fully in Algebra 2, but we do introduce it here. The concept of domain. Domain are all the numbers that can be used in place of a variable. So if you're asked to find the domain, you're finding all of the numbers that you can plug in. Okay. So this is one of the most difficult types of these problems. We need to find what numbers need to be excluded from the domain, so what numbers you can't plug in. We'll do that first. So we're going to find where x squared minus x minus 6 equals 0. Because if we find where that equals 0, we'll find what needs to be excluded from the domain. So how do I solve that?
Would it be 6?
6 squared minus 6 minus 6. How would we solve that, Tilly? You would do the snowflake. Okay. What goes at the top?
X squared will be, no, 6.
-6. How about the bottom?
1.
-1. Two numbers that multiply to give you -6, add up to -1.
Negative
No.
3, 3?
-3
-3 times 2 is -6. -3 plus 2 is -1. So we have what will help us factor. So we get x minus 3 times x plus 2 equals 0. So what are my solutions? Henry? 3 and -2. So that means if I plug 3 into the equation, I will get 0 in the denominator. I'll have 3 over 0. Does that make sense? If you do 3 squared minus 3 minus 6, do you get 0? 3 squared minus 3 minus 6. Is that 0? Yeah. Also, if you plug in -2. So the domain, this is how you state it. You state all real numbers except -2 and 3. That is how you state your answer. All real numbers, because you can plug in any number you want except -2 and 3. So the domain has you state what it is, what it can be. It can be anything except for -2 and 3. Now, if you do not want to write all that out, there is a symbol for all real numbers. So you could do this, or you could write the symbol for real numbers. That is the other way to write it. So the symbol for all real numbers is going to look like a capital R, but instead of the big line on the left side, just having one line, you actually write two lines. So essentially, it's a capital R, and then you add another vertical line on the left side, and that's the symbol for all real numbers. No one?
Will we have to know both ways?
No, but a lot of people like this because they don't have to write as much. Yep. Sure. All right, let's find, oh, I already did that. Okay. Let's do this one. So what do we want to focus on first? Pardon me? Yeah, so we're going to write the equation that makes the denominator 0 so we can find out what we have to exclude, what real numbers we have to take out of our domain. Okay, so I set up the snowflake, 2 going at the top, -3 at the bottom. Any thoughts on what that would be? Henry? Yep, good job. -2 times -1 is 2. -2 plus -1 is -3. So that's our snowflake. So I'm going to grab off the coefficients here. So it's going to be x minus 2 times x minus 1 equals 0. Can someone tell me what the solution would be then to that equation? Nolan?
I'm confused already that equals 0.
Okay. What we have to do is figure out what values we cannot plug into this equation.
Okay.
So the way we consider that is the only problem we're going to have with this algebraic fraction is if the denominator is 0. So I'm trying to figure out what makes the denominator 0. If I can figure that out, I know I can plug in every number except those numbers that make the denominator 0. So what numbers can't I plug in? Italian? 2 and 1. So when you state the domain, you state that it can be all real numbers except x cannot equal 1 or 2. Or you could write out the words all real numbers except 1 and 2. Bob?
Do we have to show the word through this one?
Yes.
Okay.
But it won't always be a quadratic expression. It could just be, let's say, 1 over x minus 4, find the domain. And when you find the domain, Bob, what would make this 4? So you'd say all real numbers, x cannot equal 4. Notice, I could do that in my head, but I couldn't do the problem on the slide in my head. So if you can just figure it out, but I don't see how you just kind of guess that, especially both of them. All right, now let's look at how, or remind ourselves how we reduce rational numbers, aka fractions. What would the reduction of 6a's be? 3/4. Now, the way I look at reducing is I look at dividing a 2 out of the numerator and the denominator. Okay? But we're going to look at it a little differently. What I'm going to do is factor the 6. So 6 is 2 times 3 if I factor the 6 into prime numbers. 8 factored into primes is 2 times 4. So that's 2 times 2 times 2 if we factor the 8. 2 times 2 is 4, 4 times 2 is 8. So dividing a 2 out is exactly what you're doing if you cancel the 2's.
Wait, is it 2 times 2 times?
Wait, could you put 2 times 4?
Yeah, I was about to say, can you just?
Sure, but I said I wanted to factor it to primes, and 4 is not prime. So in this case, that would have been just fine.
Oh, wait, no.
So this is equivalent to 3/4. So notice what I did is I factored and then I canceled. Because dividing by 2 on top and bottom is the same as canceling out 2 2's. Because 2 2's is 1. Now I want you to look at this algebraic fraction. Let's factor it. This is where the entire last chapter comes in very handy. How do I factor x squared minus 9?
You just want something.
So factoring it looks something like
Oh,
that.
X times
Let's try and snowflake this puppy. What goes in the snowflake? No one?
-2, or, wait, no, where do you get 18? On the top.
So this is just -9 on the top. Because it's 1 times -9.
Oh, so it's not with that 18, I think that 18, but,
No, we're just doing the top.
uh,
We're just snowflaking the top. Because you have to factor the top and the bottom independently. They're two separate expressions. So 1 times -9 is -9. What goes at the bottom of the snowflake? Tommy? 0. Because this is the same as x squared plus 0x minus 9. That is what that equals. So the middle term is missing, which means the b value or the coefficient of the middle term is 0. So that's why 0 goes at the bottom, and here's a 1 and a 1. Bob?
-3 and 3.
-3 and 3 are two numbers that multiply to give us -9, add up to 0. So then we have x minus 3 and x plus 3. And then we have factored the numerator. How do I factor the denominator?
You don't have to.
Well, it is not what's called a quadratic equation. Quadratic equation where the highest power is x squared. So you only use snowflake if you have x squared. So you wouldn't snowflake. But I can factor out what we call the greatest common factor.
Oh, so.
So Bob, what's the greatest common factor?
3,
Go even higher.
6.
6. And then what do I multiply 6 by to get what I started with? Chili?
X plus 3.
6 times x plus 3 equals 6x plus 18. This is just like distributing in reverse. So now, if we look at my initial example, what I did is I factored and I canceled out common factors. Are there any common factors in the numerator and the denominator? Yes. X plus 3, good. So I'm going to cancel out x plus 3. So my reduced fraction is x plus 3 over 6.
Wouldn't it be X minus?
Yes, it will. Yes, because x plus 3 cancel. So notice, in the numerator, you just have x minus 3 left, and then the denominator you have 6 left. All right, so this is it. This is the answer. One thing you want to keep in mind is that you cannot reduce without factoring. So one thing that is completely wrong is to do this and to call this a 1 and then call this a 2. You cannot do that. Yes.
Why can't you?
Okay. Do you see how 3 is being subtracted in the numerator? So follow me along this journey here. Let's say 4 ace, right? Let's say I rewrote 4 ace as 4, sorry, let's do this. 6 minus 2 over 8. Do you agree that those are equal?
Yeah.
Okay. So, what if then I said this is 1/4, canceling out one thing that's being subtracted and the other thing that's in the bottom?
Oh,
This would mean that 4 ace equals 5/4. We know that's completely wrong. So you cannot cancel terms. These are terms here. You can only cancel factors.
Would you write it out then? Or
What's that?
would you write it out then? Like the all real numbers thing?
No, because this one just says reduce it.
Oh.
So this is it. That's all we have to do there. So this is a tricky one. We have to factor the numerator and the denominator. Okay. So I'm going to do those separately. Those are separate operations. So first I'm going to factor the numerator. The first thing you guys should look for is factoring out the greatest common factor. What is the greatest common factor in the numerator? Natalia? 3. Good. Can that one be further factored?
Yes.
What would you use to do that?
Nope.
No, you're right.
Oh, right.
Yeah, you just have to snowflake it.
Uh,
And the way you know to snowflake it is this is a quadratic. In other words, it's an x squared, and you can snowflake x squared.
One.
2 and 1. So this is 3 times x plus 2 times x plus 1.
Does it matter which side you say, so I could cross it out 22? Does that matter?
It does not, because you can multiply in any order. In other words, x plus 2 times x plus 1 is the same as x plus 1 times x plus 2. Okay, so I have factored my numerator. I need to factor my denominator. So what would I do first to factor that? Yep. Chili, what would the GCF be? 2. Good. Can we further factor the x squared minus 4?
no.
Let's think of snowflaking it. It is an x squared, so we can probably snowflake it. It'd be a 0. Yep, x squared plus 0x minus 4. So it's negative 4.
Wait, what? Oh, yeah, wait, sorry.
Natalia? 2 and negative 2. So we get 2 times x plus 2 times x minus 2. And that is my denominator. So now I'm going to rewrite the original problem with my new numerator, all factored out, and my new denominator. Does anything cancel?
X plus 2.
Yep. That is 2 cards there.
And then it's the rest of it too.
Yes, so your answer is 3 times x plus 1 over 2 times x minus 2. So that, if you plugged a number into the original problem, you get the same thing as if you plugged a number into the reduced. Same thing. Questions?